Hey, what's up guys? We are back for another video, 5.4 Properties of Logarithms. So, we have learned about logarithms, we have graphed their functions, and now we're going to learn a little bit more about the properties. So basically, what can you do with logarithms? How can you change logarithms? How can you simplify logarithms? How can you evaluate logarithms? Okay? Now, every single operation has its boundaries, basically what you can do with the logarithm, or what you can do with the operations. For example, taking the square root of a plus b, we knew that this was not equivalent to the square root of a plus the square root of b. Same could be said that a square root of a minus b was not equivalent to the square root of a minus the square root of b. However, there were properties that did tell us that the square root of a times by b was equal to the square root of a times the square root of b, and the square root of a square root of a divided by b was equivalent to the square root of a divided by the square root of b. So that's the purpose of these properties. Properties tell you what you can and can't do. So always make sure that whenever you see properties of something, you're going to want to know these. This is how students make a lot of common mistakes, is because they don't know their properties. So let's make sure we understand the properties of logarithms so we don't make common mistakes. So in these properties, we're going to have b, m, and n in all of these properties, and b, m, and m are going to represent real positive numbers. Real positive numbers, okay? So, let b, m, and n be positive real numbers, and b cannot equal 1. So pretty much what we're saying here, positive real numbers, b cannot equal 1, so b has to be greater than 1. It can't be equal to, and it still has to be positive, so b has to be greater than 1. Okay? But yeah, b cannot equal 1. So b cannot be negative, b cannot be 1, m and n are also going to be positive. So, let's say that we are so in these properties right here, so this is called the product property. So if we have a logarithm base b of two items being multiplied together, these could be variables. M and n could represent variables, or it can represent numbers at times. So even though we say here m and n are positive real numbers, sometimes you can use the same properties even whenever they're not real numbers, but sometimes when they're variables. But in any case, in this we are saying that they are positive real numbers. So the product property, log base b of m times by n, is equivalent to the log base b of m plus log base b of n. Okay? So this is a property that will help us simplify and evaluate logarithms. Log base b of m times by n is equivalent to log base b of m plus logarithm base b of n. So that's the product property. So they have to be multiplied. Okay, now we have the quotient property, and quotient is division, so they have to be divided, and this is equivalent to log base b of m subtract log base b of n. Okay, these are equivalent statements. And last but not least, the power property. The power property says if you have log base b of m and m is being raised to the nth power, this is equivalent to n log base b of m. So in other words, if your argument right here is being raised to a power n, you can bring that out here and multiply it by your logarithm, and these are still going to be equal statements. Okay? So make sure you know these properties, okay? These are important properties. Always, always, always memorize your properties so that you know when to use them, and so you know that you don't do any sort of error and make common mistakes. Always know your properties. So let's go to example 1. We're going to be using properties of logarithms. So that means don't forget these. We're going to circle back to them. You're going to want to use these for these examples and for the homework. So for example 1, it tells us that log base 2 of 3 is equivalent to 1.585. Log base 2 of 7 is equivalent to 2.807. And we need to evaluate each logarithm. So, log base 2 of 3 divided by 7. What we're going to do here is use the properties of the logarithms to simplify and evaluate. So we are dividing right here. So hopefully that can give you a tip of which property we're using. So use the context. Quotient, which is division. So let's use this. So I know log base 2 of 3 divided by 7 is equivalent to log base 2 of 3 subtract log base 2 of 7. Well, here log base 2 of 3 is equivalent to 1.58. So that's this term right here. So this is equal to 1.585, and then log base 2 of 7, we have that one right here. So we can substitute them in. So minus 2.807. And whenever I subtract these together, I get negative 1.222. So we just evaluated that logarithm by simplifying and evaluating. Alright, let's go to B. So log base 2 of 21. Now it is not given to us what log base 2 of 21 is equivalent to. But what we do know is log base 2 of 3 and log base 2 of 7. Now I can rewrite 21 to be log, so I'm going to do log base 2 of 21. This is equivalent to log base 2 of 3 times 7, right? Those are equivalent statements. Well, here I'm multiplying 3 and 7, so that should hopefully tip you off that we're going to be using a product property. So this is equivalent to, if we use the property given up above, I'm referring to this statement right here. This is equivalent to log base 2 of 3 plus log base 2 of 7. So this would be equivalent to knowing that we have right here the value of these logarithms. This is equal to 1.585 plus 2.807. So this is equivalent to, if you add those together, 4.392. Okay. So here we use the quotient property. Here we use the product property. Let's see what this one might require of us. So C. So log base 2 of 49. Now 49 is divisible by 7. Also 49 is 7 squared. So there's two things that we could do here. We could write it as log base 2 of 49 is equal to, I guess I should write that a little bit more clearly, of 49 is equal to log base 2 of 7 times by 7. Okay. Now I could also go this route, so I can do log base 2 of 7 squared. From here, I can use the formula, the product property, and do log base 2 of 7 plus log base 2 of 7. Or in other words, this is basically saying 2 times log base 2 of 7. Right? If you're adding them, that means you have 2 of them. So 2 log base 2 of 7. And then log base 2 of 7, so this would be 2 times by 2.807. Okay? Alternatively, we could do this right here. We could use, so this is using the product property of logarithms, or we can use the power property here. So the power property here states that the exponent can be brought out to the front and multiplied. So like right here. So I could take this 2, bring it out front, so this is 2 log base 2 of 7. And look what we have here, 2 log base 2 of 7, 2 times log base 2 of 7. So we got there a lot quicker. So this would be equal to 2 times by 2.807, which would be equal to 5.614. So either way, you get to the same one, but I got to the answer here a lot quicker using the power property. Okay. Alright, so that's using properties of logarithms. Okay. Now, over here, what we did was we took these and we expanded them, pretty much, is what we did here. So we call that an expansion. So in this next example, we're going to talk about what it looks like to expand a logarithmic expression. And pretty much what you do is you use those product properties, those quotient properties, and those power properties in order to extend this logarithmic expression. Okay, so just note here that just because it's a natural log doesn't change anything of how we use these properties. Natural logs can still be used with these properties because natural log is still a logarithm. Okay, so expand the natural log of 5x to the 7th divided by y. Okay, so first of all, so there's a couple of things going on here. These items right here are being multiplied. This is 5 times by x to the 7th. Now this is where you divide. Anything that's in the numerator and being multiplied means that you're going to use the product property. But anything that's in the denominator means you're going to use the quotient property. So let's see if we can expand this out. So I'm going to change this to the natural log of 5 plus the natural log of x to the 7th. Okay. I guess another probably more efficient way to do this would be to show the division first. So I can change this to be the natural log of 5x to the 7th, so not separated yet. And then because we're dividing by the y, we can use the quotient property and expand this to be minus the natural log of y. So that's using the quotient property. Okay, now let's use the product property. Because these are being multiplied, this then becomes equal to the natural log of 5 plus the natural log of x to the 7th minus the natural log of y. So here I use product property. And then I could expand it even more, just a little bit, by using the power property because this x is being raised to the 7th power. So this is equal to the natural log of 5 plus 7 natural log of x minus the natural log of y, and that was using the power property. Okay? So if we were to outline a process, I would say expand the denominator first. Expand the numerator. And then expand the powers. And honestly, you can do these could be interchangeable. Honestly, if you do them correctly. Now, let's say, for example, I had 5 times by 2 down here. Or, sorry, y times by 2. Or let's just say 2y. So these are being multiplied right here. So what does that mean if I have two items being multiplied in the denominator? Would this turn out to be log base 2, or the natural log of 2 plus the natural log of y? Not quite, because the 2 is also being divided, so it's in the denominator. So that means you would have to subtract the natural log of 2 and subtract the natural log of y. So just to give you a heads up, that might come up in a problem or two. Alright, let's go to this next example where we're not expanding, but we're condensing. So can we work the other way around? So condense log of 9, 3 log of 2, log of 3. Now, I would just recommend that you kind of work in reverse here. So, anything that are powers that you can make into powers, I would do first. So, for example, I see that this 3 is being multiplied by the log of 2. So, I'm going to, using the power property, I'm going to throw that back as an exponent. So, this is log of 9 plus log of 2 cubed. And then minus log of 3. So that was the power property just in reverse. So power property. Okay? Or sorry, that would be product property. Okay. Now let's deal with these right here. So the operation between these is addition. So that means that they are being multiplied if we are to condense them. So this is log of 9 times by 2 cubed. And then minus log of 3. So this was, I had this right before. Sorry, this is power. That was definitely power property. I'm getting myself mixed up. And then this one was product. Okay, and now this is being subtracted, so if we were to condense it, it would be dividing. So log of 9 times by, well, 2 cubed is 8, right? And then divided by 3. And that was using the quotient property. Now, if I want to simplify this even a little bit more, if I do all the math, this is log of 9 times by 8 divided by 3, which should just be 24. Alright, so we just condensed the logarithmic expression. Using these in kind of like the reverse order. Okay, so those are some examples of using the properties of logarithms. Now we're moving on to what is known as the change of base formula. Okay, now change of base formula is really easy. So if you guys remember, maybe in when we first learned about logarithms, I told you about common logs. So common logs meant that you had a logarithm of common logarithms have a base of 10. pretty much is what we said. Common logs have a base 10. Now, if you guys remember that in the calculators, I told you that using this log function right here in your calculator meant that you were using a log base 10. The logs in your calculator default to base 10. And I told you that you couldn't evaluate, and because that was the case, that if you ever had a log of, like 2, or you had a log of 3, that you couldn't evaluate these in your calculator. Well, I actually did lie to you there, because you can. And that is by using the change of base formula. So the change of base formula, so if in these examples we'll be using A, B, and C, and A, B, and C, if they are positive real numbers, B cannot equal 1 and C cannot equal 1, then log base C of A is equivalent to log base B of A divided by log base B of C. This is a change of base formula. So if you have something that is you can change any base using this method, honestly, but we often use it to evaluate logarithms not of base 10 in our calculator. So you could also use this for natural logs as well, because again, C does not have to be 10, so for the natural log has a base of e, right? So you can still use this change of base formula for other logarithms not of base 10, but I'm just saying that we often use that here. So what this means is, so if we have in example 4, we have a log base 3 of 8. So we want to calculate this, and we want to use a calculator to calculate this. However, the calculator does not have a log base 3. So we're going to use the change of base formula. So this means log base 3 of 8 using the change of base. Get it? Change of base. We're changing its base. And we're going to change it to be log of A, so that would be 8. So I'm just using this formula right here. Log of 8 divided by log of 3. And this is how we can change the base. In our case, we are changing the base to 10. So basically we're changing this to be 10. And we're doing this so that we can type this into our calculator, because again, our calculators know and can evaluate log base 10. So we're going to do log of 8 divided by log of 3. So we're going to punch that into our calculator. So log of 8 divided by log of 3. Enter. And it equals 1.89. 1.893. And there you go. It's as simple as that. So we can change the base to a base of our choosing. Most of the time we're using this to change it to base 10. In this case, however, in example 5, we want to change a base using natural logarithms. Okay? And natural logarithms have a base of e. So starting with log base 6 of 24, I want to change this to be a log, to have the base of e. So I change this to be the natural log, and the natural log has a base of e of 24 divided by the natural log of 6. Okay, so this number is the one that goes in the denominator. This number is the one that goes in the numerator. It's pretty easy to remember, right? Just think of this one as the top number, and the base number goes below. Now again, natural logs have a base of e, so that is basically, that's what we're changing. We're changing to a base e. And we can use a calculator here because whenever we use natural log in our calculator, it automatically uses the base of e. So I'm going to do the natural log of 24 divided by the natural log of 6. And I get 1.774. Okay, so there you go. And that's pretty much all it is to it. That's all the change of base formulas are. So logarithms with any base other than 10 or e can be written in terms of the common or natural log using this formula. That's pretty much what this formula is for, which is basically just a means of us evaluating logarithms that aren't of base 10 in our calculator. Okay. Now, for those who might have a TA84 or a TA84 CE, you could also come to this math. So on the left-hand side, 2 buttons below the second button, there's a math option. And under this math column, at the very bottom, there is a log base. Now here, this actually allows you to enter a base of your choosing. Just FYI. But you will still need to know the change of base formula on the test and be expected to solve using change of base formula. Okay. So honestly, that does it for this video. Really short. Again, logarithms are honestly one of the more simple things of algebra. I find their properties and the way they work are very simplistic, and it's easy to recognize their patterns. Very easy to recognize their patterns. So hopefully you guys have found your own patterns. Make sure that you guys go back and watch the video if needed, or email me, or I will see you guys in class if you have questions.